Okay, so 7:45 here, and we have this beam here, and we're given that there's a thrust bearing at A and just a journal bearing at B. The thing about a thrust bearing is it prohibits motion in the axial direction. So at A, we'll have both a y direction force and an x direction force here. And then at B, we just have, since this is just a journal bearing, we just have by there. So the first thing we need to do is solve, we're trying to find the shear and moment diagrams along this shaft here. The first thing we need to do is find the reactions. So we can do that by first taking the sum of the moments around A and setting those equal to 0. Counterclockwise is positive. So we have P at a distance of A away, and that is going to be counterclockwise. So we have P times A, and then we have By, which is going to be in, PA is a clockwise direction, clockwise, so that's negative. And then we have By, which is counterclockwise at a distance of L away. And setting those equal to 0, we find out that By is equal to PA over L. All right, we can sum the forces in the x direction, and you can see here AX is the only one in the x direction, so we have AX just equal to 0. And then lastly, sum the forces in the y direction, set those equal to 0. We have AY upwards, and then we have P downwards, and then we've already found B at Y, which is PA over L. And setting that equal to get, we have then AY is equal to, let's see, what's that come out to be? P minus, let's scoot back a little bit. All right, bring AY over to the other side. We have negative P plus, we have negative AY P PA plus L, and then we'll flip the sign on that. So this turns positive, that one turns negative. All right, and we pull the P out to the outside, we have P1 minus A over L. Okay, so that's our AY. Okay, so now we have the reaction forces, we can move on to the internal forces. And so I'm going to just first start drawing from 0, from x equals, x goes from 0 to A. Right, so that's the first one I want to take a look at. So we'll draw that diagram of the shaft, and we have AY here, which is P1 minus A over L, and then we have our shear force downward and our moment here, and this distance is x. Okay, so that distance is x. Let's take the sum of the forces in the y direction and set those equal to 0. We have P1 minus A over L upwards, and then we have downwards, we have V, and that's it. So we have V is then equal to P1 minus A over L. And now we can sum the moments around x and set those equal to 0. So x is this point right here. And doing that, we have this P1 minus A over L force. That's going to create a clockwise moment, so that will be negative. 1 minus A over L. And the distance that is acting away is x. And then we have plus m here. And setting that equal to 0, we then come out with m equal to P 1 minus A over L times x. Okay, so we have those two equations now for 0 to A. For the second side, kind of from A to the end of the beam here, I'm actually going to do something a little bit different, and I'm going to draw the right-hand side of the shaft. So we have this here. We figured out By, which it was PA over L, and we still have X coming from this direction. All right. So this distance here, from here to here, is actually the total length of this L minus X. So that is the distance from here to here. So we need to take that into account when we're taking our moments around X, this point here. And positive sign convention, we have V going up like this and M like this. So let's sum the forces in the y direction here. So we have PA over L upwards. We have V upwards, and setting those equal to 0. We come out with V is equal to negative PA over L. All right, now let's take the sum of the moments around X, set those equal to 0. All right, so we're taking the moments around this point here. PA over L is going to have a counterclockwise moment, so PA over L, and multiply that by the distance, all right, and the distance X is away from the end at B here is L minus X, okay, and then we have plus M, is M positive around, no, that's negative, so let's make sure that's negative here, so that's negative M equal to 0. So solving for M, we have PA over L times L minus X. Okay. And if we want to simplify this, we can. All right, so that would be PA 1 minus X over L. We can simplify that. So we have that equation, we have this equation. Now we need to draw the shear and moment diagrams. Okay. All right, so here is the shear diagram, and we can say A is here. So from 0 to A, we figured out that V is equal to, is a constant, and that value is P1 minus A over L. Okay, so that's the value there. And then from A to the end of the beam, we have a shear of negative PA over L. So that's this value that we found right here, negative PA over L. All right, so we have that to the end of the beam. Okay, and connecting all these lines up. All right, so that is our shear diagram. Okay, let's move on to the moment diagram now. Our moment diagram, and we'll put A about right here. And the moment from 0 to A, we have, let's see, that is a linear equation. So we have a linear equation and it's positive. So something like that. And we take a look back up. The slope of that, right, that slope line is P times 1 over AL. So at x equal to A here, at x equal to A, that's this point. At x equal to A, we have a value of P 1 minus A over L times A, right? So that's our value at that point right there. Okay, now let's look at our second equation here from for x equals is in between A and the end of the beam L, and that is here, right? So if we were to put in L to this equation, so if we were to sub in L here, we would find out that we would have 1 minus L over L, which is 1 minus 1, which is 0. So at the end of the beam, we actually have the moment goes to 0. Now let's check at point A here. So if we put in A to this equation, we have PA times 1 minus A over L. And that is exactly what this value is right here. So we have this point here. So all we need to do, this equation is linear. We just need to connect those two. Something like that. And then that is our moment diagram. And we can take a look again. This value here from 0 to A actually represents our slope on the moment diagram. So the slope of this is P times 1 minus A over L. And likewise, the slope on this side is actually equal to this value over here. All right. And that is problem 745.